Okay, hi, I'm Aiden Padilla, and for my 6S193 project, I worked on implementing a genetics algorithm for training Tetris playing AIs on an FPGA. So just as a quick overview, the way this works is essentially we use a heuristics-based approach for players to make decisions where they look at next possible game states and use their own weights to sort of determine which game state would be best. And then the genetics algorithm is what updates these weights. So it uses principles of fitness, elitism, crossover, and mutation, where fitness is simply just the player's final score at the end of a game. Elitism is such that between generations, we only keep the top performing players. Crossover is that bottom players are replaced with a mixture of weights from parents, from the better performing players. And mutation is just the chance that weights will be randomly changed between each generation. And then sort of as a high-level view, the project has three major modules, which is just the Tetris module, the decision-making, and population. Most of the game logic is actually housed within the decision-making module because neither the Tetris nor the population modules need to see the game board. So the Tetris module mainly just keeps updates of score and whether the game is over or not, whereas the decision-making module is what updates the game board and determines what the next state is. And then the population module keeps track of player weights and BRAM and then makes updates to them as needed by the genetics algorithm. So more on the decision-making module, it has a few parts. It has game calculation, state generation, heuristic calculation, score calculation, max score, and then you kind of see the flow of everything here in this diagram. So it starts with the state generation, communicating with game calculation, where it generates every next possible state, and all those states go through heuristic and score calculation so that we can get the max score and then use that max scoring move to transition over to the next state. And then for the population module, it has a few main states, initialize, play, sort, crossover, and mutate. And then basically they're self-explanatory. Initialize, you initialize all of the player weights to randomly distributed values according to a normal distribution. Play has all the players play the game and then record scores and average them out. Sort sorts players by score. Crossover does all the necessary replacement of the bottom performing players, and then mutate randomly changes weights. And then all of this comes out of the FPGA via UART, and then that UART is parsed by a Python script, which then displays how all the weights change through each generation and total score through each generation. Okay, and then finally a demo. So I am going to reset my FPGA and then initialize my script and get it ready to collect data. Okay, now the COM port is open, so I'm going to start the genetics algorithm. And then you can see all the outputs pop up there, and by the time all generations are done, we'll get to see the plot of how all the weights and total score change through each generation. Okay, and now that we are done training our players after 50 generations for this test, green light comes on, we know that we're done, and we get this nice little plot of every weight and how they all changed over time. And it's about what you might expect, such as aggregate height being bad, so it gets a negative weight, or number of lines cleared being good, so it gets a positive weight. And then you can see how our score changes from generation 0 to generation 50, where total score is the sum of all players' average lines cleared per game. And you can see it goes from close to 0 to almost 20,000. And last but not least, there's one more feature to my project. Let me just reset and switch modes for a second. And pull up my terminal again. So you could actually visualize one of the players playing a game from one of the top performing players from a generation playing the game. So it starts off in generation 0, so I'll go backwards to generation 50, and this should be the top playing player from generation 50. So I'll start the game here, and it should display in terminal. Okay, and the green light is on, which means the game is done, and it looks like our player scored 326 cleared lines.